Hello and thank you everyone for attending today's webinar, Intelligent Compressed Air, Simple Steps for Savings and Safety, brought to you by Design World Magazine and EXAIR. We'd like to thank our presenter, Dave Woerner, for being here today. I'm Mike Santor for Design World Magazine, and I will be your moderator. Just a couple of housekeeping details before we get started. If you wish to tweet about this webinar anytime during or after, you can use the hashtag DWWebinar. We will also have a Q&A session after the presentations, so go ahead and submit your questions and we will ask them after all the presenters are finished. This webinar will also be available afterwards at www.designworldonline.com and of course by email. Dave Woerner is an application engineer at EXAIR Corporation and has been since 2013. Previously, Dave worked for a natural gas meter and regulator manufacturer. Dave spent his co-op years at EXAIR and graduated from the University of Cincinnati with a Bachelor of Science in Mechanical Engineering. So, without further ado, I will hand the mic over to Dave.
Thank you, Mike. I want to thank everybody for logging on today. I appreciate you taking your time out of your day to attend. If you're responsible for using, maintaining, or designing compressed air blow-offs, this will be a very useful 30 to 40 minute presentation for you. Today I want to talk about some simple steps you can take to save costs on your compressed air system. In many cases, improving your compressed air system can seem a huge undertaking with air audits, system controls, or new compressors. We want to focus on the individual steps you can take at every usage station to reduce your air consumption while still maintaining your system's effectiveness. Introduce myself. Mike did a great job. My name is Dave Woerner. I'm an application engineer here at EXAIR. Also on your chats, I have Justin Nickel. He's going to monitor what you say. If you have any questions, feel free to chat those over to him. And Mike's going to have a question and answer session at the end of the presentation. So please let me know how we're doing and what topics we need to cover more. EXAIR is a manufacturer of compressed air products. We make a variety of things: air blow-offs, vortex tubes, cabinet coolers, industrial vacuums, and housekeeping products, and static eliminators. All of our products utilize compressed air in some capacity. This is our 32nd year in operation. I ask a little bit for you to get involved here. With the webinar format, it's hard to gauge reactions and interest. The first things I want to see who's out there and to test the speed of the chat. If you get a chance during the webinar, please send us your job title or responsibility that brings you here. Also, if you know the compressed air usage in your plant or the size of your air compressor, either in horsepower or SCFM, just to give us some idea of what you might be interested in and how we can help you as well. Just let us know how the webinar works out for us. I'll give you a few seconds to get that inputted there. Today we're going to talk about intelligent compressed air. Many compressed air systems are put in very quickly and inexpensively or cheaply. We want to take the next steps in replacing those open blow-offs and homemade nozzles or homemade blow-off devices with an engineered nozzle or an intelligent solution. Later we'll get into the how, where, and what intelligent compressed air products are. First I want to talk about the why. It's very simply stated: money and safety. Compressed air is the most expensive utility in most plants. Inefficient blow-offs can cost thousands of dollars per year in wasted energy. Most estimates say that between 30 and 50% of all compressed air generated is wasted, and we want to help you find the largest sources of wasted compressed air. On the safety front, noise and dead-end pressure will be the two topics we cover. This compressed air presentation is different from most. Instead of talking to you about your system's overall capacity and supply and demand, we're going to focus on the point of use. In many cases, folks preach to audit your compressed air supply to match your demand. They only want to ensure that compressed air that you use is generated as efficiently as possible. In this presentation, we focus on trimming your demand in the first place so that you aren't just improving your efficiency, but you're reducing your overall usage. Once your usage compressed air audit can be even more effective to ensure that the air you need is efficiently produced. In other words, why would you want to install two high-efficiency 25 horsepower screw compressors when your plant only needs 20 horsepower worth of air? Finally, on top of the priceless value of safety, there are very real fines associated with OSHA violations from open blow-offs. I've seen fines from $6,000 to $10,000 for a compressed air violation. So what we'll cover today is reducing demand, replacing inefficient processes, and increasing safety. Let's get into it. The first thing we want to look at trimming your compressed air demand is homemade blow-offs and inefficient nozzles. Here we have a variety of different nozzles that we've replaced over the years in different shape and forms. We have some liquid-only nozzles here, as well as just some open copper pipes. You'll notice that many of these nozzles have cross-drilled holes. This is to allow a path for the air to escape to comply with OSHA's regulations for dead-end pressure. It may comply with that regulation, but the nozzles are incredibly noisy when they have a cross-drilled hole due to wind shear, which also may result in a safety violation due to excess noise levels that you might not have proper hearing protection for. An open-type tube also consumes more compressed air compared to an engineered solution, so it's wasting a lot of energy. On the right, here's a chart of the air consumption of an open tube or pipe. You'll see this 1/4-inch copper tube pictured here throughout our presentation. In this chart, at 80 psi, it uses 33 SCFM of compressed air. That's quite a bit and is a significant demand. On top of the usual suspects, we also have the most wanted. Here we have the compressed air usage that will generate the largest returns when you replace them with an engineered solution. Starting from the left, a crushed air gun to me is a sign for help. You try and get more force out of that gun, but this will generally not work. In most cases, what's happening is there's so much demand on a line or on your compressed air system that the gun just can't generate enough force, and you can't build up any pressure inside the compressed air system. By crimping it or crushing it, they're trying to reduce their compressed air usage and generate more velocity, but if there's no pressure behind it, it's really difficult to make any lasting results. Second, we have a manifold of open pipes. Each of those tubes is a 1/4-inch line that will use 33 SCFM. That's 13 open tubes there. So that would use 430 SCFM of compressed air at 80 psi of inlet pressure. That would be something you really want to look at for replacing with an air knife or a long, we call it an air knife. It's a linear air nozzle, if you're not familiar, but it replaces a long span there. Also, we have a drilled pipe here, a section of pipe that they can fill with compressed air, and they have openings all along the length. Depending on the holes in their spacing, this can use a tremendous amount of air. Regardless of the air usage, though, this is an incredibly noisy installation and one that you should definitely look at replacing. I'm going to go through an example here shortly. First, a little bit of background as far as how we come up with the cost of compressed air. We use this in our literature, 25 cents per 1,000 standard cubic feet generated. This is a pretty conservative number for Europe and the coast, but in the Midwest, it's a pretty accurate number by our account. And here's how we come up with that number. Let's take, for instance, a 20 horsepower compressor that uses 15 kilowatt hours. Those 15 kilowatt hours at 8 cents per kilowatt hour means it takes $1.20 per hour to run that compressor. You might have a different electrical rate that you want to replace in there, so please do that and follow along as best you can. If you have any trouble, you can always contact us with your electricity rate and the compressor itself, and we can look into that more and more. So once we have the cost to run a compressor for an hour, let's look at the time it takes us to produce 1,000 standard cubic feet per minute, or 1,000 standard cubic feet. 20 horsepower compressor puts out approximately 4 SCFM per horsepower. Over 60 minutes, that'll put out 4,800 standard cubic feet per hour. To produce 1,000 standard cubic feet will take 0.2083 hours or 12.5 minutes. That 4 SCFM per horsepower is a conservative rule of thumb. Some air compressors can make 5 or more SCFM per horsepower, but individual compressors and delivery rates will vary. You never know how much you're leaking throughout the system, so we feel like that 4 SCFM is still a very good rule of thumb. You'll see that a lot in different compressed air presentations and forums. So we take that time it takes to produce 1,000 standard cubic feet, combine it with the cost it takes to run a compressor for an hour, and you get 25 cents per 1,000 standard cubic foot produced. That's how we come up with that number. If you have any questions, please contact us. If you think that's a good number, then the rest of this will hold true, and you don't need to follow along quite so closely. If you come up with a different number, you can go through and use that as we're going through, or after the presentation, we can go back through it with you and figure out what your cost would be. Let's get to an example. How much would it really cost to run a 1/4-inch copper tube for a year, and how much energy could you save with a compressed air nozzle? There are a number of slides here of calculations. Please ask if you have any questions. So a 1/4-inch copper tube, as we said earlier, is going to use 33 SCFM of compressed air compared to a 1100 super air nozzle, which has a 1/4-inch NPT air inlet. It uses 14 SCFM. In addition to the air consumption, you also notice the noise level is almost 30 decibels higher with an open tube as opposed to an engineered solution. 1/4-inch open copper tube costs 50 cents per hour to run. And we did that by multiplying 33 standard cubic feet times 25 cents per 1,000 standard cubic feet, which was that cost of compressed air that we received, and then multiplied it by 60. So that was able to get us that 50 cents per hour to run here. The shift would cost $3.96. An 1100 super air nozzle would cost 21 cents per hour to run, so you saved around 28 cents per hour to run it. Per shift, an 1100 super air nozzle will cost $1.68. An 1100 super air nozzle saves $2.28 every 8-hour shift over a 1/4-inch copper tube. But we take that number of 1/4-inch open copper tube costing $3.96 per shift over 250 shifts per year, and that will cost $990 per year. A 1100 super air nozzle costs $1.68 per shift times 28 shifts per 1 year, which costs us $420 per year to operate. So an 1100 super air nozzle saves $570 every year over a 1/4-inch copper tube. The return on investment is 16 working days for that. So we didn't talk about any benefits from compressor maintenance, noise reduction, or OSHA compliance. all we talked about is the cost of compressed air. You can see there's a significant savings just replacing one nozzle. In a couple of minutes here, we'll talk about a case study where a customer replaced 40 of these open tubes and the savings they were able to realize. If you have any questions about how we got there, I'm sure you do. Please let me know at the end, and we'll go through that again. Let's look at a case study. This is a customer that we had that was a high-tech plastic producer. They're operating 40 machines that use crimped quarter-inch copper tubes at 100 psi. You can see each of these copper tubes here that have been smashed. You'll notice there's slight variations. This one's a little more rounded. That one definitely has a crease in the center. This one shows a little sign of the crease, but is overall an oval pattern. These had varying rates of how much compressed air they actually used, but overall it was still much higher, so we took an average of those to compare it to our 1100 super air nozzle. We actually tested those quarter-inch crimp pipes at our facility. They consumed 40.4 SCFM at 100 psi. You'll notice that 40.4 is larger than the 33 SCFM I was using in the previous example. That's because they're running at a higher inlet pressure, so they use proportionally more compressed air. 1100 super air nozzle at 100 psi will save or use 23.4 SCFM less than that 40.4 SCFM. Quarter-inch copper pipe costs $1,260.48 per year to operate. An 1100 super air nozzle is going to save $730 per nozzle per year to replace. In this example, an operational year is an 8-hour day with 250 days per year or 250 shifts per year. The company that we were working with in this case study replaced 40 quarter-inch crimped pipes with an 1100 super air nozzles, resulting in the savings of $29,200 just in compressed air usage every year, and they were able to realize that indefinitely. Really, there's no reason that will ever change. They're always going to be able to save that amount of money on their utility bills. So you can see, it might not cost a lot to run a compressed air nozzle for a couple of minutes or an hour, but if you're running continuously, that can add up to a very big cost over the years, and replacing those can be a huge savings. Talking about on the compressed air side, not so much just money, but how much compressed air you actually saved. An 1100 super air nozzle saves 23.2 SCFM over that quarter-inch crimped pipe. An air compressor produces 4 SCFM per horsepower. So to run that crimped pipe continuously, or to replace that crimped pipe with a nozzle, reduce your compressor load by 5.8 horsepower per nozzle. Replacing 40 nozzles could save 232 horsepower of compressor. When you talk about air audits and efficiency of the compressors and the load, being able to cut that demand can really have an impact. Air audits still have their place and can make a tremendous difference, but you want to make sure that you're sizing that demand properly. And being able to cut that demand is a great first step. So that's what I wanted to cover about the cost of compressed air. We'll go back to that as well here in a minute, but I want to talk a little bit about the safety benefits as well. Specifically, we're going to talk about OSHA Dead End pressure regulations and the noise directive. The OSHA Dead End pressure regulation is a tough read. I went ahead and put an interpretation up here that I got off of OSHA.gov, so you can see that. What they're trying to do is reduce the pressure, the dead end pressure, to less than 30. There's a number of different ways to do this. You can either limit your pressure incoming to the nozzle to 30 psi. You can allow some kind of regulation to control the pressure to 30 psi. For our nozzles, we prevent them from being dead-ended so that that pressure cannot build up. There's always a path for the air to escape. Show you an example of what I mean by that so maybe you can get a better understanding. Here we have an 1100 super air nozzle. You'll see, if you look closely here, that there's multiple recessed orifices that all allow the air to come out. So if you're able to block off one or two of these orifices, there's always a path for that air to escape. And then we have these fins that protect the orifices, so even if you cover the nozzle with your finger like I have done here, you're always going to have a place for that air to vent, either back down the fins or on the other side of the nozzle, which is hard to see in this picture, but there's always a path for that air to escape, and that's the key. Here we have another example of this. We haven't talked about this much, but that's an air knife that I'm holding in my hand there. That's a linear air nozzle. You'll see a variety of EXAIR's products that aren't necessarily nozzles, but use some similar features to prevent the dead-end pressure from building up. With our air knives, we only have the one opening. That opening is at least 3 inches in length, so it's difficult to block with your finger across it just being 3 inches long. Even if you do block the front of the opening, the cap overlaps that body, as you can see here, so that there'll always be a small triangle of relief for that air to escape out the side of the knife. This prevents the buildup of pressure, allowing you to comply with that OSHA regulation. All of EXAIR's products use some combination of these principles, either multiple orifices or a covered orifice, to bring you an OSHA-compliant compressed air device. You also see here another interpretation of that dead-end pressure, so you can read it there. OSHA's standard, I think, is very difficult to read and difficult to interpret. So we've done our best to provide as much information as we can. Once again, if anybody has any questions, let us know. We have a number of documents on our website that we can share with you about that. Other than the OSHA dead-end pressure, there's also the noise directive. OSHA has outlined a maximum allowable noise exposure table to protect workers from constant noise. If you're exposed to more than 90 decibels of noise in an 8-hour period, you're required to wear some sort of hearing protection or to take some steps to mitigate that noise providing your workers. You can see our 1100 super air nozzle was at 74 decibels, well below that 90 dB threshold. In comparison, a 1/4-inch copper pipe, it was at 102 decibels. Any more than 1 hour of exposure to that, and you will need some sort of noise protection for the operators or the workers there. By using an engineered air nozzle, you will reduce the noise with the smooth flow that the nozzle creates. It does not feature the intelligent compressed air product does not feature that piercing wind shear noise, which is especially painful and distracting. You'll notice this with the cross-drilled holes all the time. There's a real high-pitched noise that I associate, or I used to associate with compressed air before I worked here, and you can see a huge change in the flow, just the way we condition the air coming over the nozzle, as opposed to the sharp corners that you typically see. Just to give you some reference, a construction site is around 100 decibels. That's up near where that copper tube may be. Classroom chatter with a room full of 5th graders is probably around 70 decibels. Something you can definitely talk over. You might have to raise your voice a little bit, but it's something you can carry on your workday through. Just to give you a point of reference, 10 decibel increase means that you're going to perceive the noise as twice as loud. So that 30 decibel increase means that a 1/4-inch copper tube is perceived 6 times as loud as an 1100 super air nozzle. Wanted to talk a little bit about noise in the workplace, why it's so important. Most people just consider it a nuisance, but there's a number of facts and studies that show that it actually can make a tremendous impact on your work environment. Specifically want to call out this last line here: increased stress, reduced productivity, degraded communications and concentration, which can lead to more accidents and injuries. Anytime you're trying to train new employees or communicate with a group of people, that noise is going to intrude. And anything you can do to cut down on that to allow people to clearly communicate is going to be better for the overall safety of your facility, and that can't be overstated. So I talked a lot about an EXAIR nozzle, an intelligent compressed air product, or an engineered nozzle. What makes a product intelligent? There's a couple of things that I would want to see in an engineered nozzle. Some sort of air entrainment, nozzle designed to pull in ambient air to get the most use out of your compressed air. In the next slide, we'll talk about more what that is and how EXAIR does that. Second, we would want the nozzle to be safe, Second, we want the nozzle to be quiet, and lastly, we want the nozzle to be safe. An engineered nozzle has taken these three components and made it intrinsic to the design so that you can get the most out of your compressed air. Secondly, you're looking for some sort of manufacturing quality and consistency. Quarter-inch crimped copper pipe is going to be different, and it's going to vary from person to person who crimps it and makes it and how it's applied. Using Inefficient is going to give you that precision and that consistency so that you know it's going to work in every spot, not just where the person has set up that copper pipe just perfectly. Those are the big reasons you want to take a look at upgrading your blow-offs when you can. A little graphic here for air entrainment. Here we have an 1100 super air nozzle. You can see the primary airflow coming out of these openings here. This fast-moving jet of air creates a low pressure around the nozzle. So in this area, we're creating a low pressure, which induces the flow of free or ambient air from the environment. So any free air surrounding that nozzle is going to be sucked into the airstream and pulled in. This induced airflow is 25 times the amount of compressed air used by the nozzle. So even if you're only putting one part of compressed air or one SCFM here, you're seeing 25 or 26 SCFM flow from the total airflow. This means for a smaller amount of compressed air, we can create a larger force than compressed air alone, giving you the most effective use. I want to rehash a couple of things there. So what are the benefits of intelligent compressed air products? Saving money in operating costs. We talked about the cost of compressed air and how we can calculate that. We eliminate dead-end pressure so that we don't have to worry about an OSHA violation. We decrease the noise level, which leads us to a safer, more productive environment. Finally, one new thing, the utility rebates. There's a website, EXAIR, that you can see. It's broken up by utility. So you can go on that website, call up what your utility supplier is, and look to see what rebates they have. Utility companies, similar to what they did with compact fluorescent light bulbs, they will actually pay people or at least cover the cost to install nozzles on their compressed air system because it's such a significant user of their electricity. So just cutting on that is worth it for them so they don't have to upgrade their power plants. Please take a look at that website when you get a chance. It's specific to each utility. So I can't give you any examples because it all depends on where you're at, but it's definitely worth your time to take a look. So next steps. I took a look at my plant. I covered all the compressed air blow-offs that I have. I have some kind of nozzle on them, some kind of an air knife, some device to limit that compressed air flow. What else can I do? One of the things you might want to do is do some flow measurements. If you know what nozzle you installed, you should be able to add up all those air nozzles and their flow, and compare that to your flow measurements that you're taking from your compressor or on a branch, and that'll let you know if you maybe are missing a blow-off or two, or if there's just a tremendous amount of leaks that are causing your flow to be higher than you would expect it. Second, you want to look at flow management. EXAIR has a product called an electronic flow controller, or an electronic flow controller. That will allow you to turn your compressed air on and off. It's got a photoelectric eye so that it senses the product and turns the compressed air off when that product is not in front of the nozzle, and turn it back on when the nozzle can be useful. Simply turning off compressed air when it's not in use can also be effective. If you have a branch that's full of piping that always has compressed air to it, but no one uses it for several days or for several hours, it might be worthwhile to see if you really need to leave that compressed air all the time, because you will have leaks. Third, you want to look at leak mitigation. Finding and fixing those leaks can have a great benefit. Also want to mention down here, lowering your system pressure. If you're able to lower your system pressure, you'll actually decrease the number of leaks that you have. Let's take, for instance, a compressed air system that we run at 120 psi to a system at 80 psi. At 120 psi, the leaks are going to allow more air to flow, and there's going to be more of them because there's more pressure on the joints. Lastly, you might want to take a look at sound measurement. The easiest way to identify where you're using compressed air is just to listen. You hear that high-pitched whine of a cross-drilled hole, or the air impingement. That might be a place to take a look at for identifying open blow-offs, which could be a hazard, or inefficiencies where you can put a nozzle there and replace that to limit your use of compressed air. Also wanted to take a minute and talk about EXAIR's Efficiency Lab. EXAIR will take your current installation, whatever it is, a homemade blow-off, an open pipe, a modified gun, a liquid nozzle, and we'll test it in our lab up against our intelligent compressed air products. This will give us a force, flow, and noise, and allow you to kind of get a better benefit of what you might want to do and how much compressed air you can save. The results are confidential, and we will provide a report.
All right. Well, thanks so much, Dave. Great presentation. We appreciate it. We're going to open it up for questions now. And just a quick reminder, if you have any extra questions for Dave that we don't cover today, you can send them to him directly at techhelp@exair.com. Or, of course, you can send them over to me at msantora@wtwhmedia.com. So we'll start out with the first question here for you, Dave. We have, okay, it says, you are using the SCFM value in your air data. How does it compare to CFM?
Okay. So an SCFM is a standard cubic foot per minute. One SCFM is how much air will fit into a cubic foot at standard conditions. That's atmospheric pressure at sea level. It's around 14.7 psi and 60 degrees Fahrenheit. In your compressed air piping, your air is compressed. So one CFM can contain many SCFM inside a cubic foot, and we just want to compare pressures, comparing 80 psi to 100 psi. We want to make sure we're measuring those the same way to standard conditions.
Okay, next question we have coming in. All right, so how can I find out how much air I'm using with my current compressed air blow-off if it is not a 1/4-inch copper tube?
So, as I mentioned, you can send that to EXAIR and we can test it for you. If it's a regular orifice or pipe and you know the ID, you can also Google the discharge through a pipe or an orifice with compressed air. If you know your inlet pressure and the orifice size, you can calculate how much compressed air that you use. You can also install a digital flow meter or any kind of flow meter on your compressed air piping and add up the total that way. if you know what kind of nozzle it is too, you can also contact the manufacturer. If you bought it from somebody, they might be able to tell you.
Okay. It says, can I cycle or control the air to my nozzle? If so, how much air can I save?
Yeah, obviously we talked about that. You can cycle that air on and off. The air is going to be saved equal to the amount of time that your nozzle is on or off, so it's going to be proportional. So if, let's take an 1100 nozzle, it typically uses 14 SCFM, but you're only running it 30 seconds out of every minute. It's going to use 7 SCFM if you're cycling it on and off for only half of every minute.
Okay, so we have another question coming in. We have, let's see, do you have a chart that has the air usage for different size pipes or holes at different PSI?
I have the chart that's in that presentation with the different sizes. There's also some more charts online. For the different pressures, though, I think you're asking about, it's going to be fairly linear. It's actually linear with the absolute pressure. So let's take, for instance, the chart that we presented was 80 psi, and the quarter-inch copper pipe used 33 SCFM. If you were to run that same pipe at 100 psi, it's going to you would just multiply by 114.7, or sorry, you'd multiply by 100 psi plus your atmospheric pressure, which is 14.7, and then divide by 80 plus your atmospheric pressure, which is 14.7. So it's fairly proportional. You can just take the difference and multiply that out.
Okay.
Alternatively, there should be, once again, you can Google that and see that there's a number of different multipliers for the orifice charts and the pipe sizes. But if you have a specific, send me an email too at techhelp@exair.com. We can get you the chart really quick.
Okay. It also says in here, well, would you mind just explaining how you calculated that 25 cents per 1,000 SCFM?
Yeah, so the basics of that are you take the energy that your compressor uses and the amount of compressed air that it puts out. And I can go back through the slide if I have control, Mike. Is that true?
I'm not positive if you do.
Oh, okay, well that's fine. So what we did for calculating the cost of compressed air is took the amount of energy that a 20 horsepower compressor used, which was 15 kilowatts, and we just got those specs from a compressor. You could do the same thing with your own compressor. And then we calculated how much money it cost to run that compressor over an hour, which was we took the 15 kilowatts and multiplied it by our utility rate, and then multiplied it by and that got us our usage per hour, and then we calculated how much compressed air we could generate in an hour, and then multiplied those two things together. So you had $1.20 per hour times 0.2083. I think I made that worse than it is, but if you look back through the slides there, I think it lays it out pretty well.
There you go. So it looks like we have one last question coming in. It says, the OSHA regulation referencing cleaning, is that cleaning of persons or cleaning of something in a process?
It's the cleaning process. They specifically mention cleaning personnel, and they do not recommend doing that. Using any kind of compressed air to clean off personnel is not something that OSHA recommends.
Okay. Well, thank you, Dave, again. I think once again, I'll just remind everybody that if they do that thing where you come up with 1,000 questions after everything's over, you can always feel free to email them to Dave or myself. On the screen, you have our contact information. So once again, thanks everyone for attending this webinar from Design World. This presentation will be emailed to everyone later today and will also be available at www.designworldonline.com. You can also connect with us with all your favorite social media pathways. And of course, you can discuss us on engineeringexchange.com. Thank you for joining.
Thanks, Mike.